Guys, let's finish up this question. Sorry about that. We were saying that everything has been given in this diagram, and thereafter, they are saying define the term potential difference across the ends of a conductor. So I would want us to define what potential difference is. So we are going to use this space. So we know that potential difference is the energy transferred, or else is the total work done, is the work done to push uh, a unit of charge, a unit of charge across a conductor. So it can either be the energy transferred to move a point charge, or else to move a unit charge across a what? Across the ends of a conductor. That is what potential difference is. It is simply the energy or else the work that is used or else that is done to push a unit of charge across a conductor. We usually call this the work done to push what? Yes, the charges or else electrons around this. So we are saying calculate the potential difference across the 3 ohm resistor. What is the potential difference across this 3 ohm resistor? This is where we use Ohm's law, where we say that V is equals to IR, and we have been told that this ammeter reads 1.5 amps. So the current that is flowing through here is the same current that will flow through here. Whatsoever is coming from this end has to return to that end. So we have got 1.5 amps times the resistance here, it's 3 ohms. So this was going to be 4.5 volts. That is the potential difference. That is what? That is across the 3 ohm resistor. Now they're saying, hence, calculate the potential difference across each cell in the circuit. Across each cell in the circuit, now the potential difference will be equal to what? We can see that the potential difference here is what? Is 6 volts, because this is in parallel. So we know that voltage in parallel remains the same. And then here it's 4.5. So the total voltage would be to say the one that is in series we sum. So the total voltage V total of this circuit will be equal to 6 volts plus 4.5 volts, which is equal to 10.5 volts. That is the total voltage amongst these two cells. So here we have got one cell and two cells. So these ones, there are two cells. But they said potential difference across each cell. So we need to divide this by 2. So that at the end, we are going to find what? Our potential difference is going to be equal to 5.75 volts. If we divide 10.5 by 2, you are supposed to get 5.75. That is the total potential difference across there. So you just, I, I'm just seeing that this is not the right calculation. If I say 2 into 5, I'll get 0.25. So this one is supposed to be 5.25 volts. So I'm saying whenever you are given a circuit, you need to look into how the circuit is related in terms of what? Parallel and series circuit. Voltage in parallel will remain constant. So voltage in parallel, you would know that voltage in parallel is constant. but voltage in series is what? Is summative. And then current that is in series is constant. And then the current that is in parallel is the one that is what? Summative. Now they're saying calculate the total amount of charge flowing through the 12 ohm resistor, this 12 ohm resistor, in 10 minutes. What becomes the what? The amount of charge flowing through the. So how do we find charge? We know that current is what? Charge per unit time. And we are given the time, which is 10 minutes. We convert those minutes into seconds, our time in seconds. Well, this one becomes coulombs, and then our current will be in amperes. So all we need to know is how much of the current that is passing through here. How much of the current that is passing through there. Once we know that current, we can find the what? The amount of charge. So you can see that we said voltage in parallel is constant. So a voltage across the 12 ohm resistor is equal to what? 6 volts. So if I've got 6 volts, this is also equal to IR. The resistance there is 12 ohms. So my current, I can be able to find it. So my current will just be equal to 6 over what? Over 12. That is 0.5 amps. Because I'm saying that the voltage across parallel circuit is what? Is constant. Now that I have found my current, that is the current that is passing through the what? The 12 ohm resistor. Now I can find the charge passing through the 12 ohm resistor. This is 1.8.14. So now I'm now saying 0.5 amps is equal to the charge that I'm looking for in coulombs divided by the time, which is 10 minutes times 60 seconds, because it has to be in seconds. So my charge there is simply going to be, I cross multiply by that, it will be 0.5 times 10 times 60. And then this is supposed to give me, if I'm to punch my calculator, so the answer there is supposed to be 300 what? Coulombs. So this will be 300 coulombs. So the unit of charge is coulombs, which is just C there. The unit of charge is what? Coulombs. So it will be just what? C. So now they're saying switch S is now closed. Write down the reading on V1. This is switch S. Just allow me to go to switch S. So we are saying that switch S is now closed. If we close this switch, what happens? Let me just get to rub here so that you can actually get to see what's happening there. So if we close this switch, let's say this switch is now closed, simply means that current is also now flowing through that. What happens here on this voltmeter? You can see that the voltmeter will remain measuring the same what? The same voltage in what? In parallel. So the voltage there does not change. It will remain what? 6 volts. Irregardless of either the switch has been closed or opened. The voltage across a parallel circuit will remain the same. So V1, the reading there would simply be what? 6 volts. It will remain the same. It will remain the same. 8.2 now is saying grade 10 learners conduct an investigation to determine the relationship between current and potential difference at a constant temperature. They use a rheostat, which is a variable resistor, to change the current flowing through the circuit at a particular time, and they measure the corresponding change in voltage. The values obtained are given in the table below. So here the learners are investigating the relationship between what? Current and potential difference. And that relationship is given by what? By which law? It is given by Ohm's law. The relationship between current and potential difference is given by what? Ohm's law. Now they're saying write down the name of the law being investigated. This is just what? Ohm's law. Plot a graph of voltage against current on the attached graph paper. So you would have seen, you know that Ohm's law says that current across a conductor is directly proportional to the voltage across that conductor, given that resistance is what? Is constant. So if they are directly proportional, you need to draw a graph that is going to have a constant proportional line graph there, where you'll be having voltage against what? Current. So you just plot a voltage against your current there, and the graph would be like this. So let me just get to illustrate like I've done on the previous graph. Given that given that you have that, let me just get to check if I don't have that graph here. Yes, because this is just simple and straightforward. So this is the graph. You draw the values of your voltage on your y-axis, and then the values of your current on your x-axis. And this was what you were supposed to draw there. When you plot 0 against 0, 4 ohms against 0.3, 8 ohms against what? 0.6, 12 ohms against 12 volts against what? 0.9. That is what you are supposed to draw there. So that was the graph. Now let's return to our question so that we can see what is it that they wanted us after that. After drawing the graph, they now say, what does the gradient of the graph represent? The gradient of the graph, gradient of a voltage against current. It will be voltage over current. This represents resistance. So you would have just came and said what? Resistance. You can see that this represents what? Resistance. Voltage against what? The gradient would be voltage against current. That represents what? Resistance. So that was our question paper. Let's meet on the next coming question papers to come. So we are going to try to find as much question papers as we can, and then we use those for what? For our revision. So thank you so much, guys, for being together. Sorry for the glitches, but I'm sure next time we just get to do everything all at once. We'll be able to. Maybe the time there we can be able to manage our time. So let's meet in our next classes.